Hello, hello. It's it's a dreary day up here in Scotland. The sky is clouded, the air is moistened, cold. It the weather's lost the charm it had in autumn, but it's not quite winter yet either. In other words, it's a perfect day to do some coding. We're solving Advent of Code. This is a programming competition of sorts. It's it's one problem per day from the 1st of December through to the 25th. And we're solving it in Livebook. This is the Elixir answer to Jupyter notebooks. So it's a web app, you can write a bit of code, and then the code is executed and the result is printed below it. I think this makes it very nice for live coding a solution to a competition problem like we're currently doing. But in addition to just executing code blindly, it also has fancier features like, here, we're generating an input, and then we can read the input a bit lower. Right. Yeah, Livebook is pretty amazing for this. So, back to Advent of Code. The story arc we're going through is that we're trying to save Christmas by fixing the snow machine. However, we have done everything except for fix the snow machine so far. We started by getting launched out of a trebuchet towards an island, then helping an elf with his little colored blocks puzzle, helping another elf fix a gondola machine, taking the gondola up to a mountain, but then it turned out to not be a mountain and in fact be a sky island, helping the elf solve his scratch cards, calculate his scratch card winnings. Then we took a boat to yet another island where we saved the island from a famine. And yesterday we played a little game with boats, with boat races. I imagine today we'll be painting the bike shed and tomorrow we'll be shaving the yak, or something of the sort. So, without further ado, let's get going. Let's see what day 7 is all about. So, day 7, camel cards. Your all expenses paid trip turns out to be a one-way 5-minute ride in an airship. At least it's a cool airship. It drops you off at the edge of a vast desert and descends back to Island. Oh, the context here is that we're trying to get sand so that we can filter the water for the snow machine. Did you bring the parts? You turn around to see an elf completely covered in white clothing, wearing goggles and riding a large camel. Oh, it's an elf on a camel. That does not rhyme. Did you bring the parts? She asks again, louder this time. You aren't sure what parts she's looking for. You're here to figure out why the sand stopped. The parts for the sand, yes, come with me, I will show you. She beckons you onto the camel. After riding a bit across the sands of Desert Island, you can see what looks like very large rocks covering half of the horizon. The elf explains that the rocks are all along the part of Desert Island that is directly above Island, making it hard to even get there. The rocks are all along the part of Desert Island that is directly above Island. So we're again on floating islands. Normally, they use big machines to move the rocks and filter the sand, but the machines have broken down because Desert Island recently stopped receiving the parts they need to fix the machines. You've already assumed it'll be your job to figure out why the parts stopped when she asks if you can help. You agree automatically. Because the journey will take a few days, she offers to teach you the game of camel cards. So we're not even fixing the machine, the rock machine today. We're playing another game. Camel cards is sort of similar to poker, except it's designed to be easier to play while riding a camel. In camel cards, you get a list of hands, and your goal is to order them based on the strength of each hand. A hand consists of 5 cards labeled one of Ace, King, Queen. I have no idea what this one is called in English. T, Oh, this is 10, so 9, 8, 7, 6, 5, 4, 3, or 2, and there's no 1 because that will be the ace. The relative strength of each card follows this order, where A is the highest and 2 is the lowest. Each hand is exactly one type, from strongest to weakest. They are 5 of a kind, where all 5 cards have the same label. You're not really supposed to be able to have 5 aces. 4 of a kind, where 4 cards have the same label and 1 card has a different label. Full house, where 3 cards have the same label and the remaining 2 cards share a different label. So notably, the cards don't have to be in order. 3 of a kind, where 3 cards have the same label and the remaining 2 cards are each different from any other card in the hand. 2 pair. So the difference between a full house and a 3 of a kind is that in a full house, the pair of cards is the same card, whereas in a 3 of a kind, they are different cards. 2 pair, where 2 cards share one label, 2 cards share a second label, and the remaining card has a third label. 1 pair, where 2 cards share one label and the other 3 cards have a different label from the pair and each other. High card, where all the cards' labels are distinct. Hands are primarily ordered based on type. For example, every full house is stronger than any 3 of a kind. So every full house is stronger than 3 of a kind. If 2 hands have the same type, a second ordering rule takes effect. Start by comparing the first card in each hand. If these cards are different, the hand with the stronger first card is considered stronger. Start by comparing the first card in each hand. Do we have to sort the cards before comparing the first card? If these cards are different, the hand with the stronger first card is considered stronger. If the first card in each hand have the same label, however, then move on to considering the second card in each hand. If they differ, the hand with the higher second card wins. Otherwise, continue with the third card in each hand, then fourth, then fifth. So 332 and 2AA are both 4 of a kind hands, but 332 is stronger because its first card is stronger. Similarly, 788 and 7788 are both a full house, but 7788 is stronger because its third card is stronger. And both hands have the same first and second card. Alright, so we're not allowed to just sort the cards in each hand for convenience. And when doing the second level of comparison, we ignore the triples and the pairs and so on. We just go through the cards in order. To play camel cards, you are given a list of hands and their corresponding bid, your puzzle input. For example, this example shows 5 cards. Each hand is followed by its bid amount. Each hand wins an amount equal to its bid multiplied by its rank, where the weakest hand gets rank 1, the second weakest hand gets rank 2, and so on up to the strongest hand. Because there are 5 hands in this example, the strongest hand will have rank 5, and its bid will be multiplied by 5. So the first step is to put the hands in order of strength. 32T3K or 32T3K is the only pair, and the other hands are all a stronger type, so it gets rank 1. KK677 and KTJJT are both 2 pair. Their first cards both have the same label, and the second card of KK677 is stronger. K versus T. Right, K versus T. So KTJJT gets rank 2, and KK677 gets rank 3. T55J5 and QQQJA are both 3 of a kind. However, which is the stronger one? Q is stronger than T. So QQJA has a stronger first card, so it gets rank 5, and T55J5 gets rank 4. Now you can determine the total winnings of this set of hands by adding up the result of multiplying each bid with its rank. So 765 is rank 1, 220 should be KTJJT, yep. So the total winnings in this example are 6,440. Find the rank of every hand in your set. What are the total winnings? Okay, so we just need to sort our input based on these rules. And these rules aren't all that hard to compute, especially given that we can just write a comparison function that does this. Our comparison function won't be particularly good, but won't be particularly fast. But it doesn't need to be because it's 5-digit, it's 5-character strings. We can just do the comparison manually every time. What does our full puzzle input look like? This does not look particularly big, so we still have 5. Can I make this bigger? Yes. We still have hands of 5 cards, and then this is less than 1,000 things, less than 1,000 hands, so we can absolutely just sort it. Right, let's get going and start with part 1. We're doing this in Livebook, and we're going to create a new notebook. This is going to be called AoC 2023 Day 7. Let's save this so that we never lose it. We're going to need Kino as a dependency because we'll want to read input from our users, well, from me. The first section is going to be called helpers, like it always is, and then we're going to have the example input. And we're going to have the full input. This is one really nice thing about Livebook, that we can have widgets in addition to just plain code evaluation. We're going to copy our example here, and now we can just read it later. Oh, let's add the section first. Let's call this part 1. Right. And now we can just do Kino input read example here. And there you go. We have the text of the example. And this is much nicer than just hard coding this into our source code file. And it's much more convenient than putting it in some random file that we then have to read in. Let's also copy our full input since we're going to need it later. Right. We don't need to have the full input open anymore. And now we can get to work. So we've read the input as a string. Next up, we're going to split it on new lines. It feels like every day starts in exactly the same way. We have a trailing empty string at the end here because there's a trailing new line at the end of the input. So we just trim. Okay, so now we have 5 entries. Each entry is the hand and its score. Are we calling this a score? We're calling this a bid. So each line contains a hand and a bid. So here, next step, we're going to enum.map because we have to do something on each line. And then each line we're going to string split and then turn into a tuple. Turn into a map, in fact. So first off, string split on space. And now we have lists of 2 elements for each line. And we just assign this to hand and bid. And then here we're going to return a map so that we can access the fields easier. Not hard, hand. Right. And this is almost correct, but we're going to need to do arithmetic on the bids later, so let's also convert the bids to integers. All right. Next up, we need to sort these. So the next step is we need to sort these so that we know the rank of each hand. In order to do this, we're just going to do enum sort by, and for each, then we're going to pattern match on the hand, because only the hand matters when sorting. And we're going to return hand. And now this should sort them in alphabetical order based on the hand. This is of course not what we want, but it's a start. Next up, I want to see the documentation for sort by. I remember you can give it a comparison function. Sort by. Right, so you give it the list you want to sort, something to map the list to the value you want to sort, and then a sorter. And the sorter is a what? We can see here, the sorter is a function that takes 2 elements and returns a boolean. This presumably is either whether it's strictly greater than or equal. Is it greater than? It has to be greater than or equal, right? There's no example where they give it just a function. There are examples where they give it a module, though. Sort by allows the developer to pass ask or desk as the sorter, which is a convenience for less than or equal to and greater than or equal to. All right, so I claim I should be able to just pass a function here. And we're going to call the function, we're just going to define it inline, which should work. So this is going to take a and b, and it will return a greater or equals to b for starters. And let's see if this compiles. It does. And now if I do less than or equal to, it should sort these in the opposite order. So with 32 decay at the top. This works. All right, so now we need to implement the sorting for these strings. And although I said we're going to do it inline, actually let's put it in the module because this is going to be a big function. So it's going to be called AoC compare hands. We have to put it in the module because Elixir doesn't like functions defined at the top level. And in fact, let's call this part 1. I've been meaning to call them part 1 every day, but I always forget. Right, so we again have A and B, and then we just do A less or equal to B, and this still runs. Right, here I need to use the inline function syntax. So this is saying we're referring to the compare hands function, which takes 2 arguments. And this still works. Okay. So now we need to implement the actual comparison. The first level of comparison is based on the type. If it's a 5 of a kind, a high card. So we're just going to write a function that takes a hand and returns whether it's one of these types. Oh, and every card has a type, because even if all of the cards are different, then this is still called a high card. All right. So, hand type. It takes a hand, and then it does something. So the first thing we're going to do here is sort the hand. So we're going to do string to char list hand. Sort. And in fact, we don't need to sort. We don't actually want sorting here. We want to turn this into a map of occurrences. Do we have something that already does this? Frequencies. Frequencies sounds like something useful. Returns a map with keys as unique elements of enumerable and the values as the count of every element. So we can just do enum frequencies. Yep, enum frequencies. So this is not called sorted, this is called fs. And then we are going to do a case. We actually need to pipe this into a case. Is it the case? Not quite. Let's see what this actually returns. So here, what happens if we call part1 and type of T55J5? What does this return? This returns the character mapped to the number of occurrences it has. But we don't actually care about the characters. We just care about the number of occurrences. So here, we next pipe this into map.values. And this should give us a list of the frequencies. Now, I don't know what the sorting rules for a map are, so we're also then going to pipe this into enum sort. And can I do sort by dusk? Is this a valid thing? Yes, all right. Let's split this up into multiple lines to make it more readable. So here, we're turning our hand into a list of characters. Then we're computing the frequencies for each character. We don't care about the actual characters, so we just care about their frequencies. So we get the values of the map, and then we sort the values in descending order. So we always have the highest one first. And now we pipe this into a case. All right. So 5 is one possibility. And how are we going to write this? We have how many types of cards? We have 1, 2, 3, 4, 5, 6, 7. 7. So let's say that this thing is called a screw it. Let's just do this the nice way, and then we can do it the ugly way if we need to optimize. So let's assign this to names. 5 of a kind. Then we can have 4 and 1, and this is 4 of a kind. Then we can have 3 and 2, and this is a full house. Right? This is a full house. Then we have 3 of a kind. 3 of a kind. Then we can have pairs. What's this called? 2 pair, 1 pair, and high card. So this is 2 pair, one pair, and high card. Now, fun enough, doing it like this actually lets us basically translate this awkward phrasing directly. Like this looks really, for instance, 3 of a kind, where three cards have the same label, and the remaining 2 cards are each different from any other card in the hand. Like this is a very specific way of describing this kind of hand, and it's a bit awkward to say out loud. But it happens to match exactly what we're writing here. All right, so now if we run this, this is indeed a 3 of a kind. And if I replace this j with another 5, this should be 4 of a kind. Yep, and this is 5 of a kind. 5 of a kind of 5s. Great. Okay, so now going back to our compare hands. How do we do this? First we need to compare the hand types, and then we need to compare, then we just need to sort lexicographically, I think. Perhaps in a descending order. So, compare hands. Case, hand type of A and hand type of B, do, and. Right, so if A is 5 of a kind, and B is 5 of a kind, then we just compare A and B lexicographically. Then we can just do string compare. There's no string compare. Okay, does this work manually? I think it has to be this. Yes. Okay, otherwise, if it's 5 of a kind and anything else, then it's false, because 5 of a kind is greater than anything else. Next, 4 of a kind and 4 of a kind. This is, again, if they're the same kind, then we just compare. Otherwise, 4 of a kind is greater than everything else. Next up is full house. Full house and full house less than or equal to B, and otherwise full house is the greatest one. This is a very explicit way of writing it. We could have coded these as numbers and then compared numerically, but this is more explicit. Let's just do it the right way, because I don't want to write any more of these. Okay, so next we're going to do hand strength. If it's 5 of a kind, it's 7. If it's 4 of a kind, it's 6. I'm picking the numbers arbitrarily, but I am doing it so that we end up with a 1 on high card. Full house is 5. 3 of a kind is 4. This here is not just 4, it's 4 of a kind. Here, after 3 of a kind, we have 2 pair. Then we have 1 pair. And here we have high card, which is 1 at the bottom. Now we could combine these two, but just looks a bit nicer like this. Okay, now going back to our compare hands. We can now just do this the easy way and do hand type A, and A is less or equal to hand type of B and B. And this should just work, because Elixir's compare a total ordering of terms should first compare the first element in the tuple with the first element in the other tuple, and then it should compare, and if the two first elements are equal, it should go back to comparing A and B, the second elements in the tuple. Okay, did this work? So we're sorting by weakest to strongest. Okay, this looks like gibberish. Yeah, this doesn't seem like it worked. So it put the 1 pair here, then a 3 pair. So it put the 1 pair, 3 pair, so sorry, 3 of a kind, 3 of a kind, 2 of a kind, and then 2 of a kind again. Right, so these are called 2 pairs. Let's just see what this actually outputs. How do we do this? Instead of sorting, we're just going to print this nicely. And then dot map, then, and we're going to output I output S, and mapped to hand strength of hand. And strength. And it has to be in the module. The following arguments were given to part 1 hand strength. Right, not hand strength, hand type. Right, so first off, did it identify them correctly? Let's put this on a new line. Make it easier to read. So, this is indeed a 1 pair. This is 3 of a kind. This is a 2 pair. This is another 2 pair, and this is a 3 of a kind. They agree, right? No, it says one's a 4 of a kind. This is not the example. Here's the example. 1 pair, 2 pair, 1 pair, 2 pairs, and 2 3 of a kinds. 1 pair, 2 pairs, and 2 3 of a kinds. Okay. Let's just quickly also see the hand strength, just to make sure it doesn't do anything weird. And strength. All right, so our strongest cards are 3 of a kind, and our weakest card is a 1 of a kind. Yep, this looks right, so why did our sorting not work? Well, our sorting didn't work because we did hand type instead of hand strength. So here we have hand strength. Here we have a second hand strength. And now here we comment out our little debugging, and we uncomment out our sorting. So now how did it sort it? It sorted the 1 pair at the top, then the 2 pairs, then the 2 pairs. Sorry, then the 2 pairs, and then the 3 of a kind. And did it sort inside correctly? It sorted K before T, which is wrong. It should... Right, this is not actually lexicographic, is it? Yeah, this is the ordering of the strength, and this is not going to be the actual ASCII ordering. Okay, so we need a sorting function for these as well. Let's just do card strength. And it's going to be card strength of 2 is 1. Do this better. So if it's C, and C in 2 to 9, then it's going to be 2 minus 1. And we're going to check in a second if this actually works. Okay, then we have T, this is strength 9. Then we have J, this is going to be strength 10. Then we have Q, this is 11. Then we have K, this is 12. And finally we have Ace, and this is 13. And is this correct? A is the biggest, then K, Q, J, T, JT, and then it goes all the way down to 2. Alright, now just to check, part 1, card strength 13. Oh, here it's not 2 minus 1, it's C minus 1. Okay, we have 2. Now we go all the way up to 9, this should be 8, and now if we do 10, this should be 9. Okay, so card strength works. We just now need to take the cards here and then map them through card strength. But we're doing the same transformation twice, so let's write a function for this. Let's call it hand comparator. It takes a hand, it has to be a binary. We're messing with sufficient types here that I'd really want to check to make sure that we don't accidentally pass it something else. And then for our hand comparator, we're going to return hand strength of hand type of A. So this is the first level of comparison, and then for the second one, it's going to be A piped into enum string to char list enum.map card strength. And let's write these in the same style, so with lots of pipes. So it's A piped into hand type, piped into hand strength. This presumably needs to be in parentheses to disambiguate. No? Undefined variable A. Ah, indeed, it's called hand. Was I wrong that this needs to be in parentheses? Seems to work. Yep, still works. Okay, and here when we compare our two hands, now we're just going to do hand comparator of A less or equal to hand comparator of B. Okay, how did the sorting go now? So we start with the weakest, and then we have KT, which is smaller than KK, and then T is smaller than Q. So Q is our rank 5 card, right? Are both 3 of a kind, so the first Q gets rank 5, yes, and T5 gets rank 4. Let's write our ranks as well. Enum dot with index, and we start from 1. So QQ is 5, T5 is 4, then KK is 3. Is KK 3? KK is 3 and KT is 2. KT is 2. And by process of elimination, 3, 2 is 1. Right, so next we have to compute our total winnings, which is the bit multiplied by the rank. And then we have to sum these up. Okay, so this is num.map fn. Now we only care, this now takes a pair. The first is going to be our map, and we only care about the bit this time. And then we have the rank. And we return bit times rank. And then this we sum. This gives us 6440, which is indeed our answer. So now let's try this on the full example. This gives us this large number. We triggered the Livebook bug there, but let's see if the answer is correct. That's the right answer. We are 1 gold star closer to restoring snow operations. Let's continue to part 2. So, part 2. To make things a little more interesting, the elf introduces one additional rule. Now J cards are jokers, wild cards that can act like whatever card would make the hand the strongest card type possible. To balance this, J cards are now the weakest individual cards, weaker even than 2. The other cards stay in the same order. So it's A, K, Q, no J, and then T down through 2, and then J. J cards can pretend to be whatever card is best for the purpose of determining hand type. For example, QJJQ2 is now considered a 4 of a kind. However, for the purpose of breaking ties between 2 cards of the same type, J is always treated as J, not the cards it's pretending to be. JKK2 is weaker than QQQ2 because J is weaker than Q. Now the above example goes very differently. 32T3K is still the only one pair. It doesn't contain any jokers, so its strength doesn't increase. K6677 is now the only 2 pair, making it the second weakest hand. T5, KT, and QQ are now all 4 of a kinds. T55J5 gets rank 3, QQJA gets rank 4, and KTJJT gets rank 5. With the new Joker rule, the total winnings in this example are 5905. Using the new Joker rule, find the rank of every card in your set. What are the total new winnings? Alright. So I'm just going to reload this to get Livebook back into a good state. So how do we do this? Well, we can just brute force it, because there's only... Alright, so here's my thinking. We have, let's say, we have QQ. Let's take one of their examples. What was their example here? QQ, let's take this one. QJJQ2. QJJQ2. So the question is, what's the actual rank of this card? In the simple logic, this is a 2 pair. But we now have the jokers, which can become any card. But the only cards it makes sense for them to be are the other cards. Like, there's no reason why you'd ever want this to be, say, a 3. Because you could instead make it a 2 or a Q, which will definitely be a higher rank thing. So there are only really 2 possibilities for the J's to be. And it also doesn't make sense for the J's to be different cards, I believe. They always have to be the same card. So we can just use this and just generate the only two possibilities, which are Q2 to Q2 and Q, 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 Q2. And then we can compare, we can get the ranks of these hands and then just pick the highest rank. So really, the only thing that has changed in our part 1 is the hand type function. The hand strength function is the same. We just need to have a much more complicated hand type. We need to have a hand type that does something special about the J's. Right. Let's start and let's see what we can do. So first off, we are going to make a new section. Let's call it part 2. We're going to make an Elixir block, and then we're basically going to copy a lot of the above. So we start with just having the entire part 1 copied. Let's focus on it, and now we switch back to the example since it's shorter. We comment out the part where we actually do the final computation. We'll uncomment it later. For now, we just want to see what we generate. So using the part 1 logic, this would be a 1 pair. And this is a 3 of a kind, but really it should be a 4 of a kind. So where am I? Here. I'm here. Let's just say type here is, let's make this code look a bit nicer so that we don't get confused. Then here hand strength is just going to be a type. This still runs, yes. But now instead of hand type 1, hand type, we're going to do part 2 hand type. Because that's the only thing that really has to change. Now let's write it. I'm again adding a guard just to make sure we don't pass the wrong argument by mistake. And here let's just say 1 unknown. And now it should return. Right, it will error out, of course, so let's just say high card. Yeah, high card. Or we could, of course, say part 1 hand type. And now it will give us the old output. So this is going to start very similar. Oh, and actually here, let's stop including hand strength, because that just makes everything a bit more annoying to write. Right? Yes, and now I can write unknown here. Good. I wanted to be able to do this because we're now going to incrementally code this hand type function, and I want to see the output of it. So first off, we're doing our char list thing again. So string to char list. Next, we need to compute frequencies again, but this time we do care about what yes, we will care about what the characters are. It's not called protocol chars not implemented for. Oh, yes, we can no longer print this normally, so we're going to inspect it here. Right, so now we have the frequencies. One of these is a J. I don't know which one is a J. There's one J here. That's not helpful. It's probably 74. Yes, J is 74. So we need to now, generate multiple, for each of these maps, we need to generate multiple possibilities. Basically, we want to replace the J's with every other possible character. Okay, I don't know how we're going to do this, but we're just going to call it gen replacements. That's gen replacements. So this takes a map, and the most interesting thing in it is that J is mapped to num_j's. Let's call it, num_j's. It's fine. And we're also going to need a map for it. Have J's. And this still runs. No function clause matching. Right. It fails on one of them because there are no J's in that function. So let's also have gen replacements of map. If there are no J's, we're just going to return a list with map as the only element. So now here, this one doesn't have any J's, so it returns just the one map. This one doesn't have any J's either. And the other two have J's. Okay, so now here, the first thing we're going to do is map without J's. This is going to be map.delete map J. Am I right in thinking that delete is the name of the function? What does delete do? Deletes the entry J for a specific key. I wonder if we can use Elixir's matching syntax to match out the J. So say if we have A is 3, B is 4, C is 5. Then we assign this to a map. And then can we do, so if we do A.A map, does this work? This does not work. Misplaced operator. Okay, we cannot remove the element like this, but we can remove it with just the map delete function. So now we have the map without J's. And now we're going to iterate over every key num and num_k's. Let's call it X, since X is not one of our card letters. We go over map without J's, and then we do something. What do? We do map.put into map without J's. We put X, and the value of X is going to be num_x's plus num_j's. So for example here, where we have T55J5, we want to try to put J, we want to replace J with a T and a 5. So we can have either 4 5s, which is this one, or 3 5s and 2 T's. And this seems to work. And again, the reasoning here is that it only ever makes sense to replace a J with one of the other letters in the string. Honestly, it probably only makes sense to replace it with the letter with the highest number of occurrences, but yeah, we're just going to play it safe and not think about this. Okay, so now we have gen replacements. Next up, we are just going to map over all of the replacements and call part1.handType. The following arguments were given. Where are we calling a toChar list here? It doesn't like getting called on a map. Hand type expects to be called on a string, but we can fix that. Here, hand type. So hand type here when it's called on a binary. And then we're also going to have hand type when it's called on a map. And when it's called on a map, we just do this. And here we just pipe this into hand type. And now it should work. Yes. So the first one the first 32T3K is a 1 pair. Then T5J5 is 4 of a kind and a full house. Oh, that's interesting. I was thinking that I had just said that we might want to replace J just with the letter that has the highest number of occurrences, but that's wrong because I think a full house is better than a 4 of a kind. Is it? Full house? No, 4 of a kind is better. So never mind. Probably still wanted to do that. Then 2 pair. Right, then this is a 2 pair, then this is another one with J's, so it can either be a full house if you replace it with a K, or 4 of a kind if you replace it with a T. And this can either be a full house or 4 of a kind. Okay, so this is all written. I should really stop saying okay like that. Or maybe not. Okay, we can comment this out. We can uncomment this out. So now for each hand, we want to compare hands. We're going to need a new comparison function. This is going to be part 2, compare hands. So let's copy this into part 2. Okay. Compare hands still does exactly the same thing. Actually, let's put this at the top to match the ordering from the previous part. And now hand comparator is the interesting one. So we take hand, and then we pipe it into hand type, which is now going to give us a list. So we can't just call hand strength on it. We have to first do a num.map part 1. Just for correctness sake, this should be called hand types plural, since it returns a list. Okay, then we map it into part 1 hand strength. This is going to give us a list of hand strength, and then we just want a num.max. Yes, because we only care about the strongest hand strength. And then for the second level of comparison, we have to do card strength again. However, card strength has been modified, and J is now the weakest card. So we copy card strength as well. It's kind of funny that these two parts are almost identical, but they share almost all of the code, but the code is slightly different in a way that makes it unpleasant to share. Okay, so J is now the weakest card. This returns a 0. And then the other ones are just fine. So here, for the hand comparator, again, we get the highest hand strength for all of the hand types we can compute with this hand, and then we take this actual card, convert it into card powers, and then we just do the comparison. So now, let's comment this out and let's see what ranks we get. So 32-3K, the 1 pair, is still rank 1. Yes. But then T55 is rank 3. T55 is rank 3. QQQ is rank 4, QQQ is rank 4, and then KK6 has to be rank 2. And where is it? QQ is rank 4, KTJJT is rank 5. KTJJT is rank 5. Where's KK6 in their example? Oh, here we go. KK6 is a 2 pair, so it's the second weakest hand. I really dislike the style of writing where sometimes you write a number and sometimes you write a number with digits and sometimes you write it with words. It makes scanning the text really hard. Okay, let's uncomment this. So the result for the example is 5905, 5905. And now if we do this for the full, we get an empty error. Where? We get an empty error in enum.max. So there's some hand in there that doesn't have any hand strengths, doesn't have any hand types. Oh, there's a hand with that's all J's, isn't there? That's how you get this error. Yeah, here we go. So if it's all J's, then... Well, I know how we fix this. When we do get gen replacements here, we're also going to return one map where we just replace it with J. So basically the original map. Right, so it is literally the original map. How do we insert it into the 4? I don't think we can. So we just do map. Is this actually valid Elixir syntax? It looks pretty gnarly. It should work because the 4 returns list. Right, okay, and now we got an answer. We triggered the bug, but let's see if it's the right answer. That is indeed the right answer. We have one more gold star, and we have completed day 7. Excellent. Excellent. Oh, and now we can actually see what it's drawing. It is slowly drawing a map of the archipelago we're going through. This is kind of like One Piece, except a lot less exciting. Okay, let's clear clipboard. Let's have another quick look at this. What can we share? Can we share anything more between these two parts? Well, the parsing is exactly identical, so we can put the parsing in its own module. So here, helpers, we're going to do... I don't want this search anymore. Okay, def module, helpers. And then we have the def read input. Okay, let's indent this. Okay, so now we have a read input function. And we can replace the little bit at the start of both of our parts. This is helpers read input of full. And when I run this, it shouldn't change the output. It did not change the output. And here as well. And this should also not change the output. It did not change the output. Right. Can we share anything more between the two parts? card strength is almost the same. The only real difference is that J is special. Of course, we could do this in a more data-oriented way and just have a map from the card letter to the strength of it, and then look up the value in the map. And that would make it easier. Now, that wouldn't actually make the code look any nicer in one instance, but it would allow us to overwrite the J easily, so we could deduplicate these to card strength a bit. But the problem with that is that doing it even once, generating that map is going to be probably twice as long as this, because we'll have to enumerate any one of the digits. So I'm going to claim not worth it. Hand strength is not duplicated. Gen replacements is about as short as it could be. This would probably look better with a map. Yeah, let's just, instead of a 4, let's just do an enum here. And this still runs. And now can we shorten this even further? Not really. We could use an update here, but the FN is just going to be longer than duplicating this. Hand types. Can we... these two lines are duplicated, but again, deduplicating them won't actually shorten our code, and it will just make it harder to understand. So I think this is it. I think this is our solution for today. This was not particularly hard. I guess it took a bit of careful coding with the card strengths and the hand strengths, but not that much careful coding. Like this, if I found this in the code base I had to maintain, I think I'd be pretty okay with it. It's completely readable and completely maintainable. What do the stats look like for today? I guess everybody's solving all of it. Kind of. Okay, so numbers for yesterday increased by about 20,000. So there's about 20,000 people solving these problems after us. But then the numbers for today are lower than yesterday. At around this time we were at 40,000 yesterday. Surprising. It seems like some people still haven't actually solved part 2. Well, on the upside, we're going to get a nice Christmas tree here as more and more people drop off. Alright, that's it. Thank you for watching, and see y'all tomorrow.